Welcome back with another classic interview question. Okay, problem for today's video is search a 2D matrix. So we have to design algorithm that searches for a value target in m by n integer matrix. This matrix has the following properties. Integers in each row are sorted in ascending from left to right. Integers in each column are sorted in ascending from top to bottom. Okay, this is the problem. For this problem, I am going to show you two approaches to solve this problem. Okay, the first approach is we simply check every element in a matrix. Okay, that is the first approach. And the second approach is we are going to make use of these two properties and then implement the solution. That is a kind of optimized solution. Okay, let me show you the first approach. That is, let me create a function search 2D matrix equals to function which takes two arguments. One is a matrix and the other one is target. Okay, so inside this function I simply use for loop to loop through each row of matrix. Okay, each row of matrix, and then condition if row contains, that is using includes, I am checking the target is present in the current row or not. If row dot includes target equals to true, then we simply return true. Okay, that means we found the target. So if the target is not found in matrix, we simply return false. Okay, that is after for loop. This is the function for the first approach. Let me show you with the example. Let's copy this and then const. After that, simply call this method function for which pass the matrix as input and then target. Now let's run this and then see what is the output. Okay, we got error here because I did a mistake in target typo. Okay, now let's run it. You see, true. So this approach is working, but the problem with this approach is it's very slow because we are searching each and every element inside a matrix in worst case. Okay, let's say if you don't have, if let's say if you the target is at last row, that is, let's say it's 30, then we should search in each and every element. That is a worst case. So in that case, the time complexity is big O of m into n. Okay, for example, let's say if you have a matrix of size 1000 by 1000, we may need million operations in worst case. Okay, that is the problem with this approach. Okay, now let me show you the second approach. Okay, let me copy this. Okay, for that, first let me discuss the strategy I'm going to use for this second approach. Okay, so for this second approach, I'm going to start from the top right corner. Okay, top right corner, that is, let me show you that. So I'm going to start from the top right corner, that is from 15, because this position, from this position we have perfect information. Everything to the left is smaller, everything below is larger. Okay, this means with one comparison we can eliminate an entire row or entire column. If current element greater than target, go left. That means eliminate the column. If current element is less than target, okay, go down. That is eliminate the row. Okay? Like this, we can eliminate either row or column in each comparison. Okay, let me show you how to do that. Okay, so for this, what I'm going to do is I'm going to start with row 0. Okay, I'm going to start with row 0. Okay, inside this, let row equals to 0. That is top of matrix, and then column is matrix of 0 dot length -1. That is top right corner. And then what we have to do is we should continue search. While we are in matrix boundaries. Okay, while we are in matrix boundaries. Matrix dot length and call greater than or equal to 0. Okay, so inside this, the first condition is, as I said, let's check if the current element matrix row column equals to target. If the current element is equals to target, we simply return true. That means we found the target. Else if current element is larger than target, if current element is larger than target, that means as we discussed, we simply go left. That is, we simply move left, meaning eliminate the current column. Okay, for that simply decrease column index. Else, okay, else we simply decrease row, increase row index, because we are going down. Okay, we are going down. Okay, after that, after the while loop, if the target not found, we simply return false. Okay, this is the solution using the second approach. Let me show you the output, whether it works or not. Okay, simply copy paste this and then okay, now let me run this. Let me comment and then run it. See, we got it true. So with this approach, we eliminate the number of operations required to search for an element even in worst case as well. So with this, the time complexity is big O of m plus n instead of big O of m into n, the worst case. Okay, thanks for watching. If you like the video, please do like, share and subscribe for more technical videos. Thank you.